Oh, but it's just because you press a button, right? Just because you press a button, right? Yeah. Okay, cool. That's fine. It'd be more disturbing if that was where the recording started. Okay. What's that? Anyway, let's go on here. So, oh man, time flies when you're having fun. So, not right now. So that means that we can compare these series by the limit comparison test. And what does the limit comparison test tell us? Diverges. How do I know that the sum k equals 1 to infinity of 1 over the square root of k diverges? That was like half hour ago, right? We proved it over here. The point is that the a sub k series is ugly, messy, yucky, right? But if you look at it, man, it's really just the square root of k with some noise, right, in the denominator. So intuitively speaking, you'd expect you could compare it to the 1 over the square root of k. It doesn't give me much joy to think about trying to come up with some kind of explicit inequality. I mean, you sometimes can do that, fine. But limit comparison is nice because you don't have to come up with this inequality, right? You can just calculate the limit of the quotient. It's almost like a L'Hopital's rule for limit for series in some sense or another. Okay, how do you prove it then? Well, if a sub k over b sub k goes to L as k goes to infinity, what's that mean? What does that tell us? That tells us that we can choose an epsilon between 0 and L. So and for n greater than or equal to some n, we'll have what? We'll have the absolute value of a sub k over b sub, n. A sub n over b sub n minus L, right? Less than epsilon, right? But what does that mean? That means we can unfold that. That's minus epsilon less than a sub n over b sub n minus L less than epsilon, right? Which implies what? L minus epsilon less than a sub n over b sub n less than L plus epsilon, right? And then that gives us that L minus epsilon times b sub n is less than a sub n is less than L plus epsilon times b sub n. And once you have that inequality, notice that the L minus epsilon and the L plus epsilon are both positive, right? These are both positive numbers. And it's just all right in here. Once you have this inequality, you can just think about this inequality and the results of the theorem become obvious. If a sub n converges, right? Once we have this, then we can use the basic comparison test to complete the proof. If a sub n converges, right? Then here we have what? We have some other, you can think about the sum L minus epsilon times b sub n converges when the sum a sub n converges. And we have that the sum over L plus epsilon b sub n diverges when a sub n diverges. But the thing is, those are just numbers, L minus epsilon and L plus epsilon, which you can pull out, and they don't alter the convergence or divergence of the series, and that proves it. So the limit comparison is a pretty quick consequence of the limit comparison is a pretty quick consequence of the basic comparison test if you just write out the inequality that you get from that limit, like this. Anyway, if this was too fast, I will prove that again at the start of class tomorrow in the other section, You can look at the video there if you want to. I don't know. Anyway, thanks, guys. Yeah, you can.